Okay, today we're going to go over CC1 2.3.2 review and preview. Problem 65 says to draw a generic rectangle to help us calculate each product. For each part, you need to write the total dimension times the total dimension equals the sum of individual area parts equals total area. For example, the diagram at the right shows that 12 times 27 equals 200 plus 40 plus 70 plus 14. When I add all of them together, it equals 324. So, part A, we're multiplying 73 times 42. So I'm going to write the numbers in expanded form. So I have 70 plus 3 and 40 plus 2. Just like before, we're going to multiply to find the area of each rectangle. The first one we're going to find is this top left one. 70 times 40, 7 times 4 is 28. And I have to make sure those zeros are there because I'm multiplying by my tens. The next one we're going to find is the upper right, which is 3 times 40. 3 times 4 is 12. And then I put my 0 for my tens place value. Then I'm going to find the area for my bottom left, which is 2 times 70, which is 140. And this last one is 2 times 3, which equals 6. So I need to write it as 73 times 42 equals 2,800 plus 120 plus 140 plus 6 equals, and I have to find the total, so I'm going to write them vertically so I can add them a little easier. Start here. 0 plus 0 plus 0 plus 6 is 6. 0 plus 2 plus 4 is 6. 8 plus 1 plus 1 is 10. And 2 plus 1 is 3. So this equals 3,066. I'm going to do the same thing for part B. My expanded form for 125 is 100 plus 20 plus 5 times 80 plus 1. So I'm going to start with 80 times 100. 8 times 1 is 8, and there would be 3 zeros. 8 times 2 is 16, and I put 2 zeros for 80 and 20. 8 times 5 is 40, plus another 0 for my 80. 1 times 100 is 100. 1 times 20 is 20. 1 times 5 is 5. So for this one, I'm going to blow it up a little bit. So 125 times 81 equals 8,000 plus 1,600 plus 400 plus 100 plus 20 plus 5, which equals, and I want to add all those together, so I'm going to put them over here. 8,000 plus 1,600, 400, 200, oh no, sorry, not 200, 100, 20, and 5. 5 plus zeros, 2 plus zeros, 6 plus 4 is 10, plus 1 is 11, 8, 9, 10. It's 10,125. Okay. We're going to move on to problem 66. So it says we need to complete the table of multiples below. We need to count by 3s and 4s and extend the table so that it has 14 columns of values. So I'm going to double check to make sure I have 14 for you already printed. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So we're just completing the table. We put a table of 14 on there for you. So I'm going to fill in my 3s first. So 3 times 5 is 15, then 18, 21, 24, 27, 30, 33, 36, 39, 42. Then I'm going to go to my 4s and count by 4s. 12, 16, 20, 24, 28, 32, 36, 40, 44, 48, 52, 56. For part A, I want to write down all the numbers that appear in both rows. Describe any patterns. So this first one that I see is 12. If I keep going, 24, 36, that should be all of them. So I'm writing them down. I have 12, 24, 36. What pattern? What would come next in this pattern? So if I think about it, 12 times 2 is 24. 24 times 2 is not 36. Okay, so it's not multiplying by 2 each time. 24 plus 12, or 12 plus 12 is 24. 24 plus 12 is 36. If I were to continue it, my next one would be 48. So the pattern that I notice is that it's growing by 12. Each time. Okay. For part B, what is the smallest multiple of both 3 and 4? Well, that would be that first one. It's 12. As a reminder, this is the least common multiple. Okay? So if I were finding, for instance, if I had fractions like 2/3 plus 1/4, my common denominator is going to be 12. My least common denominator, because my least common multiple is 12. Write 3 more numbers that are multiple of both 3 and 4. So we already have 3 of them written down from our chart. The next one, like I said, would be 48, and then 60, and then 72. Moving to problem 67. Jenny has been saving her babysitting money for a class field trip to Washington, D.C. She wants to save $200 over 3 months. She saved $53 the first month and $67 the second month. Okay, so we need to estimate without calculating the amount that Jenny needs to earn during the 3rd month to meet her goal. So her goal is $200. She saved about $50 and about 70 for the first 2 months. So I'm going to guess that she has around $120, which means that she needs $80, or about $80. That's what this squiggly line means, for the 3rd month. Okay, now we're going to show how Jenny could calculate the amount she needs to earn. So I'm going to add $53 and $67. So 3 plus 7 is 10. 6 plus 5 is 11. Plus 1 is 12. Look at that. It was $120. So if she's calculating it, she would really want to do 200 minus 120, which would give her $80. Now, I want to explain how I estimated 53. If I round to the nearest 10, I got $50 because the 3 makes it go down, right? So it doesn't make the 5 move up, so then the 5 stays the same and everything else turns to 0. The same thing here. I rounded to the nearest 10. So I would look at the 6 and then the number next to it, which is a 7. So the 6 would go up to 7. And then everything else would be zeros. That's how I got 50 and 70. Okay, problem 68. Find 3 fractions that are equivalent to 3/8. Explain your method. Okay, I have 3/8. I need to find 3 equivalent fractions. Now, I'm going to explain my method first. So, if I multiply the numerator and denominator by the same number, I will get an equivalent fraction. Okay, now I have 3/8. What I mean by that is if I multiply 3 by 2 and 8 by 2, I'm going to get 3 times 2 is 6, 8 times 2 is 16. I'm going to get 6/16, which is equivalent. I could multiply the top and the bottom by 10. That'll give me 30 over 80. I could multiply the top and the bottom by 7 and get 21 over 56. They are the same. Okay. Problem 69 says that Janelle and 3 of her friends bought 4 smoothies for a total of $3. If she purchases smoothies on another day for herself and 9 of her friends, how much money will she spend? So we need to figure out first, well, how much is one smoothie? Okay, so they bought 4 smoothies for $3. So if I take 3 and divide it by 4, okay, well, okay, 4 doesn't go into 3. So then 3 minus 0 is still 3, and I'm stuck where I'm at. But we can add a decimal point And the decimal point just makes it so I can keep going and create a decimal as a result. So I'm still going to bring down my 0 like I would. I didn't change my number. 3 equals 3.0, and I could keep adding zeros. They equal each other. So I'm going to bring my 0 down. 4 goes into 30 7 times. So 30 minus 4 times 7, so minus 28. 30 minus 28 is 2. I don't want a remainder, so I'm going to add another 0 here. Because again, I don't change my number. So I'm going to bring down that 0. 4 goes into 20 5 times. 20 minus 20 is 0. So I'm finished, but my last step is I need to bring this decimal up. So one smoothie is 75 cents. So if she's buying one for herself and 9 of her friends, she's buying it for 10 people. Okay? So what I can do is multiply 75 cents times 10. Okay? Now, 0 times 5 is 0. 0 times 7 is 0. 0 times 0 is 0. I have to put in a placeholder because I'm moving over to my tens place value. 1 times 5 is 5. 1 times 7 is 7. 1 times 0 is 0. I add them together. Okay. Now, when I'm looking at this, my decimal, I have 2 numbers to the right of the decimal place. So my decimal place needs to go 1, 2 over. So it cost her $7.50. Okay. As always, if you have any questions, please don't hesitate